The next point, it is optical fibers and communications. That is the third units, that is the optical resources, that is the LEDs, lasers, pin diodes, avalanche photodiodes. We will discuss in details in the laser diodes, that is this laser, that is the amplifications by stimulated emissions and radiations. That is, this is the coherent lights. It is provides the optical emissions without the inherent gain, that is the mechanisms that results from the inherent incoherent light outputs. In this, the light of the basic principles which is governed to the operations of these optical sources, it is clear that is the operations of the laser, it must be discussed in some order to provide by the appreciations of functions as of an optical resources. That is, we concentrate on the first general lasers actions. That is the, it depends on three parts. That is, these slides, it is basic operations for the lasers, that is the absorption, spontaneous emissions and the stimulated emissions. Now these parts, that is the first, this laser diodes, that is the single transmission, that is the optical fibers, it is called as the laser diodes. And this laser diodes, it is the light emitting diodes, that is emits lights through the glass lens and reduced to the signals. That is the laser diodes, it is also called as the injection laser diodes. It provides the following components, that is the photodiodes, laser diodes, a glass lens as the fronts and the fibers. These parts we discuss in the basic introductions of the laser diodes. Now, this is the laser diodes, that is the sunlight is passed through the, then that is the multi frequencies, that is non-coherent, that is one into many, that is only one input, that is like as the suns, and output, it is the multiple frequencies, that is the non-coherent lights. Then second one, we use the bulbs, that is the single lights, that is the non single frequencies and the non-coherent lights. And we have to use the laser lights, that is the single frequency, only one input and only one output, that is like as the single frequencies coherent lights, that is the laser diodes. Now, what is the principle of laser diodes? That is the main three parts of the stimulated absorptions, stimulated emissions and the spontaneous emissions. Now, first is the stimulated absorptions, that is the interactions of lights with matter through the takes place and discrete packets of energies, that is called as the quanta. These called as the photons. That is the quantum theory of suggests that is the atoms that exist in the only one energy, that is the discrete energy states, one such as the absorptions and emissions. This light causes through the to make a transmission from one discrete energy to the another discrete energy. This frequency is absorbed by the emitted radiations and the difference of energy, that is the difference between the higher energy state to the lower energy state, that is the E2 and E1. We can be in difference of these two energies, that is the E is equal to E2 minus E1, that is the higher energy minus lower energy. That is called as the this. Then find out the Planck's constant H. This discrete energies, it states that the atoms, it is considered to be electrons occurring electrons occurring a particular energy levels, that is relative to the nucleus. These different energy states for the atoms, it corresponds to the different electrons configurations, and the single electron transition between two energy levels within the atoms can be noted that this is the energy absorptions. This is the parts for the absorption, that is the initial test 2, that is the final state absorptions. There is the two energy states, level atomics where the atom is initially lower energy state E1 and the photon with energy E2 minus E1 is incident to the atoms. It may be excited into energy state E2, that is throughout the absorption of photons. This process is sometimes referred to as the stimulated absorptions. Then, when the atoms is initially higher energy state E2, it can be make a transition to the lower energy state E1. It is providing to the emission of photons at a frequency correspond. This emission process can be occur in the two parts, that is the stimulated emissions and the emissions in the atoms, that is the lower energy state in the entirely random manners, and the stimulated emissions when the photons having energy is equal to the energy difference between two states, that is E2 and E1, that interacts the atoms in the upper energy state to the lower energy states. These two emissions, it is the random nature of the spontaneous emissions. Now second one is the stimulated emissions, uh, and third one is the spontaneous emissions. Now third is the discuss here spontaneous emissions. These spontaneous emissions, it provides the light, it's emitted to the electron transitions from the large number of atoms. It gives the incoherent radiations. It is similar to emissions process, that is the semiconductor provides basic mechanisms for the light generation within the LEDs. It is the spontaneous emissions. Now third is the stimulated emissions. This stimulated emission process which gives the laser its the special properties for the optical sources. These photons it is produced by the stimulated emissions is the identical energy to one caused by the light is associated with the same frequencies. That is second part of the light is associated with the stimulated, and the stimulated photons is in the phase and has a same of polarization processes. In contrast to the stimulus emissions, that is coherent radiations is obtained. This means that is the when atoms is stimulated to emit light energy by an incident wave, the liberated energy can add to the wave in the constructive manners. It provides, that is the amplification process. It occurs in the these parts of lasers, that is main three parts: absorption, spontaneous emissions, and the stimulated emissions. Now this is the constructions for laser diodes. The laser diodes is made up of in the semiconductor diodes. These semiconductor diodes, that is the p-type and n-type semiconductors, in between in the intrinsic layers are used, that is the output for the lasers. These output for lasers, it is the depends on the p-type and the n-type diodes. Then the p-type and n-type diodes, that is allows to the semiconductor optical sources. It necessary to the some properties of semiconductor materials, that is regards to the p-n junctions. It is referred to as a semiconductor crystal. It is the no impurities or the lattice. It is said to be the intrinsic semiconductor layers. This energy band, this is the parts for the construction of laser diodes. Now there are the main parts of this laser diodes, that is a metal contact, p-type and n-type semiconductor by using the intrinsic semiconductors, and the other is last is the metal contacts. Now this is the laser diodes PI characteristics. The laser diode PI characteristics, this is the main parts of this characteristics. It is used in the laser diodes. These laser diodes, it is some junctions of parts that is used in the current versus optical powers. It is suddenly changes, that is parts if the current is constant, current increases, this optical power is constant, then current is nearly also increases, that is current power is also increases. Then one sudden change, that is the region of the spontaneous emissions parts, that is there are three junctions or the threshold current is, that is the suddenly change these currents, that is the region of stimulated emissions, that is the pi characteristics of the laser diodes. Now how to make a laser diodes, it is the driver circuits, it is used in the driver circuits, it is used in the IC LM317s, that is the three main parts, input, output and the adjustables, that is 9-volt battery are used here, and output is the laser diodes, that is laser diode driver circuits, they adjust to points of the laser diodes. Now applications of laser diodes, that is first is a consumer electronics, that is used in the CD, DVD players, laser printers, fiber optic communications and the barcode readers. Medical machines, it is used in the laser diodes are used in the machines, it is used to remove unwanted tissues, eliminating the cancer cells, non-invasive and contrast surgeries, etc. Autonomous vehicles, that is laser diodes technology is used to making the LIDAR systems, it is implemented for the autonomous driver. Now scientific instrumentations, these laser diodes are used in the devices for used for remote contactless measurements, spectrometry, range finders. Industrial applications, that is used in laser diodes are used to the source of high intensity lasers beam for the precise cutting of materials. They are also used in the 3D printing to soften the substrate levels. Then advantages of laser diodes, it is the low power consumptions, low cost of manufacturing and operations, operable for the long hours, easily portable due to the small size and the internal architectures, highly reliable, it generates highly efficient light for the instruments. Then next part is the modulation in laser diodes. This is the modulations for the laser diodes, it is used in the laser diodes, that is parts for direct modulations and the indirect modulations. The direct and indirect modulations, they are the only for two parts, internal modulations and the external modulations. We have to use the laser diodes, it is the external modulations, it is used in the laser driver, laser diodes, and then the modulation process takes place. This modulation process, it is used in the modulated signals, that is per times, voltage per times, that is the light outputs, that is it is used in the converted to the powers, that is the laser parts. In the direct modulations, it is used in the time signals or the square wave signal input is applied to the laser drivers and it is converted into the laser diodes. These parts, it is called as the direct modulations of laser diodes. Now this is the parts for the signals. We have to use in the driver circuits or the laser driver are used in the three signals, that is the analog signal, square wave signals and the digital signals. Analog signal, that is a continuous change, it is the signal that is called as analog signal. Digital signal, it is the discrete change, and the square wave signal, it is a digital format, that is the like as the 0 and 1's conditions. Now direct modulation signals, it is applied here, that is the input laser diode output into versus times, and electron density is required here and the output parts is also required. Then next part is the what is avalanche diodes or APD, avalanche photodiodes. These avalanche photodiodes it is mixed to the simple diodes in also as the p-type and n-type semiconductor are used here. That is that is the part for these junctions. That is p-type and n-type materials. It is used in these parts like as the like as the this PN junction diodes, that is the reverse bias photodiodes, or the both depletion regions and the diffusion regions. This deflection and diffusion regions it is required here to the semiconductor materials. It is used here in the parts for avalanche photodiodes. These avalanche photodiodes, that is the internal gain and the responsibility is better than that of the PN and the PIN photodiodes. It is more sensitive. The internal gain for the better signal to noise ratio it can be obtained with the external amplification process. These avalanche photodiodes it is used in the variations of PIN diodes. These semiconductor materials are used to here. It is a spectral range for the SEMS. It is a avalanche photodiodes. There is a N plus and P plus. It is heavily doped semiconductors. See the diagrams, and it is the nearly intrinsic materials. Most of this incident light it is absorbed in these regions, and the electron hole pairs are generated. Most of the electrons move towards the P regions, and the maximum voltage is dropped across the P and J regions. This is the multiplication for the electrons. This is the multiplication for the electrons only. That is the holes that get generated drift towards the P regions. These diodes are having the excellent linearity over the optical power levels. It is ranging from the fraction of nanowatt to the several for microwatts. Its power is received at the receiver is more than the 1 microwatt. Then APD is not used, that is the avalanche photodiodes. Then because of the pin diodes, it is a power level provides sufficient responsibility and is sufficient for the large signal to noise ratio. This internal gain for the APD it depends on the temperature. The gain is normally decreases as the temperature rises. This is because the higher temperature admit the free path between collisions is small and many carriers do not get chance to the reach of required velocities for the producing of secondary carriers. It is used to the APD for the temperature compensation. It is need to the expand for the temperature ranges. This is the working of the avalanche photodiodes. Then next is the pin diodes. The pin diodes it is clear that is the PN junction, simple PN junction diodes. These simple PN junctions photodetector we have to see that the frequency response it is limited to the junction capacitance, and the diode capacitance it can be reduced by the use of intrinsic semiconductors. The layer P and N layers it is the electron hole pairs are generated when the light is incident on the intrinsic regions. That is the generated carriers are now outside these depletion regions. The electron hole pairs then the drift is randomly into the depletion regions and the delayed displacement current is produced. The type of semiconductor materials and the energy of incident photons it determines the penetration of incident of lights. This is analyzed to the above circuits. These circuits that is the 0 to 63% rise time of these junction diodes. The photodiodes, it should be the capacitance of few picofarads or less. For getting low capacitance value, the surface area of diode, it should be small, good coupling, and area is not reduced below the core of attached optic fibers. These circuits, it is rise time or the transit time which is the large regions, that is limits for the speed response, or the fast pin diodes. Rise times is limited to the transit times. It is range from about the 0.5 to 10 nanoseconds. It is the lowest rise time, it is less than the 100 picosecond has been attained for the pin diodes. This is the characteristics of pin diodes and the avalanche photodiodes.